Hello, everyone. Welcome to this Net Zero Carbon Summit fireside chat. I'm John Gallagher, Senior Editor at FreightWaves, and joining me today is Eric Gebhardt. Eric is the Chief Technology Officer for Wabtec and is responsible for the company's global technology and investment strategy and new product development. Welcome, Eric, to the Net Zero Summit.
Glad to be here, John.
So just to start off, Eric, could you provide some background on Wabtec and explain what the company does?
Yes, Wabtec has been a leader in the rail space for the last 150 years. It was founded in 1869 by George Westinghouse when he designed the air brake system. And we've been continuing to invest in technology and developing technology since then. A couple of fun facts. About 1/5 of all the world's freight moves by Wabtec locomotives today. If you look at positive train control, which was just put into place in December of last year, after about a 12-year rollout, all of the Class 1s chose Wabtec for positive train control. So we do the overall systems that control the trains. And then almost all transit vehicles today have Wabtec equipment, whether it's the braking system, the doors, the HVAC, other equipment that may be part of it. We operate today in about 50 countries, and we have about 27,000 employees.
Gotcha. That's a big part, obviously, of the rail industry. So this conference is about getting net zero emissions in the freight and mobility space. So how do you see the rail sector contributing to the goal of net zero emissions?
Yeah, I believe that the rail sector has a large part to play in this. It's already the lowest emitting, the safest, and most economic way of moving freight in the U.S. today. If you look at it from a per ton mile basis, dramatically lower emitting and safer than moving the same by truck. And with our extensive rail network that we have in the U.S., 140,000 miles of track in the U.S., by far the largest around, and it gives us the ability to move it quickly, to move it in an economic way. And with the rail going up, or the freight going up by about 100%, doubling by 2050, this really is an area that by moving some of this traffic more to rail to expand how much goes by rail, and then decarbonizing rail, it gives you a great opportunity to really help decarbonize the system.
Mm-hmm. And your company's president, Rafael Santana, he recently testified before Congress here in DC on the company's Freight 2030 initiative. Could you tell us about this vision and what you hope to accomplish through it?
Yeah, this is a really exciting initiative that Rafael did speak in front of Congress about, and it's around a couple of key things. One, how do we create zero emission locomotives? So hydrogen hybrid locomotives, battery electric locomotives. We're already doing a lot on the battery electric side. Now we're going to move more into hydrogen with this, and then how to get more freight by rail. How do you take the existing infrastructure that exists today and get 50% more traffic on there by better signaling, better controls methodologies, AI techniques, and actually increase the amount there? And when we look at these two things working together, if we did those first two, we could eliminate 120 million tons of CO2 per year by doing those two things. And that's about 2% of the total CO2 emitted in the United States. So it's a good bit.
Yeah, and so the Freight 2030, so does that involve, I thought I heard Mr. Santana talking about public-private partnerships. I think he mentioned Carnegie Mellon and Genesee, Wyoming, and I think even Department of Energy.
Yes.
Okay, so that's part of the whole initiative, is it?
Yeah, so when we look at this initiative overall, we believe it's a large enough initiative that we want the government involved in this. So we're talking with the Department of Transportation, Department of Energy, others there. The committee that Raphael spoke in front of was the Transportation and Infrastructure Committee. We signed up Carnegie Mellon to be part of this. They are one of the leaders on artificial intelligence and logistics today, as well as robotics. They have a couple of institutes they're working with the government already, so we're partnered with them. Then Genesee and Wyoming is the largest short line in the U.S., and they're working with us to give us access to track, because this initiative overall is there's a research component of it, but then it's also how do you productize it? How do you get demonstration units? How do you prove it on the tracks and actually have that and then get it adopted by the customers? Because innovation only works if somebody buys it at the back end. And that's really what we want to look at this entire system. And we want to, as quickly as possible, get from where we are today with battery electric and the success we have with that to how do you get hydrogen hybrid operating and the entire ecosystem. So how do you charge battery electric locomotives? How do you create the hydrogen ecosystem around this so that the entire system is decarbonized?
Gotcha. And just briefly on the battery side, before we get to hydrogen, I understand that BNSF Railway is working with the California Air Resources Board. They're testing this Wabtec battery, 100% battery electric. Is that right? Is that going on right now?
Yes. In fact, we just wrapped up the demonstration there, and I was fortunate enough. I got to ride on the last run of the locomotive, so I spent about 25 hours on the locomotive during the last run there. And it's exciting. It's a 2.4 megawatt hour battery electric locomotive. And in the runs, we've done over 13,000 miles of operation with it in revenue service. So it was going from Barstow to Stockton and back again. It was running that route there over to Tehachapi Pass and some of the interesting grades that we have out there. And over that time, 11% savings in fuel, 11% savings in emissions on this. So it's a battery electric locomotive put between two diesel electric locomotives. And then because of the regenerative braking and the charging that takes place, we can save 11%. And we also had the opportunity to run it in battery only mode, where it was just the battery doing the hauling as part of that. So if you're in, say, a non-attainment zone, a heavy emission zone, there's ways to do this. So a lot of great testing. The next version of this is going to be a 6 megawatt hour or more version of this, and it can save up to 30% on fuel, 30% on emissions. So it's exciting technology, has run very well with BNSF and CARB, and now we're ready to take on the next challenges.
And so basically, it's going to be you want to roll that out and commercialize that.
Correct. We are already quoting this. We're quoting it at the 6 megawatt plus range is where we're already quoting today. And again, it would run in a consist with one or two other diesel electric locomotives, and then it's the regenerative part. So every time the train would break, you're creating that energy again. And it was great to see how much energy could actually be captured, because the amount you leave with and the amount you end with is marginal compared to how much you actually generate while you're on the rails.
Gotcha. So there's obviously a lot of costs and fuel savings costs there and efficiencies. So why not continue down that path? Why shift to hydrogen fuel cells?
Yeah. So the key there is how much energy you could initially put in the batteries. So when you look at that, typically a diesel electric locomotive would be going with about 5,000 gallons is how big the gas tank is. The amount of energy that we can put into the batteries is significantly less than that. So you still do need an energy source while you're riding. So the batteries can help you in between on the braking side. Moving to the hydrogen creates that energy source. Now we'll have the hydrogen hybrid locomotives, and the hydrogen will be producing the energy on this, and we'll go ahead and be able to go ahead and have the hydrogen take the place of the diesel electric is really where we're trying to go with this.
Could you tell us what the biggest technology barriers are to hydrogen rail applications, and what research and development is needed to overcome those barriers?
Yeah, when we look at hydrogen, it's going to be the fuel cells will be the biggest technological challenge we need to overcome to get those ruggedized enough. If you think about a fuel cell operating inside of a passenger vehicle, one of those probably does 100,000 miles over its lifetime. If you look at rail, rail will do 100,000 miles a year and at high power during that time. So it's a very rugged application. Even on the batteries, to go back to the batteries, during the time I was on the train in that 24-hour period, it charged and discharged 2.5 to 3 times over that. So if you look at a typical solar application, it might be one discharge per day. A lot of electric vehicles, much less than that. The harshness of the application is really what we have to pay attention to, plus the vibrations, the shock and vibes, those types of things that are taking place there. So we're already in discussions with some of the fuel cell providers about how do we ruggedize that overall. The second thing is going to be around the hydrogen ecosystem, how to make that cost effective. And I see that as a technical challenge also, because you got to bring that cost down to where it's equivalent to what a diesel is. So a kilogram of hydrogen has about the equivalent energy content of a gallon of diesel, if you think about the efficiencies, because fuel cells are 60% efficient, and you have a diesel engine is about 40% efficient. So you got to you look across there, and we have to make sure that cost is coming down, and then we have to make sure the availability, the charging infrastructure, the refueling infrastructure, all of that has to come along as part of this. All of this is doable. There's research phases of it, but then it's a productization phase of it that we really want to pay attention to, and we want to make sure this is economically viable, because the best technologies are the ones that are economically viable, and that'll really pull the industry towards this technology.
And could you say just again, Eric, what the infrastructure needs would be, or nationally, to be able to do this, to pull this off? Yeah.
What makes me excited about this, if you look at the number of refueling stations across the rail network, it's about 2,000 to 3,000 fueling stations across the entire nation. When you look at those the numbers here, if you look at the same thing for the trucking industry, it's about 150, 200,000 equivalent. So it's where we will be able to pinpoint, we'll be able to go after certain routes, certain trains, various different things as we build out this ecosystem overall. And it'll be whether it's central production of hydrogen or local production of the hydrogen, there'll be some storage facilities, how to charge. There'll likely be a tender that'll go behind the locomotive in order to give the range that we're looking for here. So a hydrogen tender where you use liquid hydrogen, most likely liquid hydrogen where you can get that much energy into the tank. So it's building out that entire ecosystem.
So as you know, President Biden just sort of rolled out his big infrastructure plan recently, and as part of that, he was devoting about $80 billion to rail. Now, a lot of that was a bulk of that was to Amtrak issues, but also to bolster federal grants and loans that would support freight rail as well, and electrification. So I was just interested, Eric, in just your general thoughts on the infrastructure plan as it pertains to the rail sector.
Yeah, and we're excited, as was mentioned earlier. There, we're working with the government to get some funding towards these programs here. We think what's being done here is a step in the right direction. We can go ahead and utilize this with a public-private partnership, pull in some of the national labs, pull in academia, pull in other industrial companies to really build this out, because the opportunity is so large here. If we look at the freight side of this, where we could eliminate 120 million tons per year by decarbonizing this piece of the network, and then really work with the trucking part of the industry and the ports and others to just optimize the entire network overall, and continue to decarbonize more and more of the freight sector.
And you mentioned, I want to go back a little bit because you mentioned positive train control and how Wabtec was kind of part of the whole class one rollout of that. So basically allowing trains to operate closer together so you get better use out of available track capacity. I guess that's kind of a main factor of PTC as they call it. So, well, I mean, I understand it's not directly put out there to reduce emissions, but can you tell us how it may indirectly at least contribute to the net zero goal?
Yeah, and here's how I piece this together. If we look at positive train control, it's a safety overlay over the network to make sure that all of the movement authorities are followed properly. They want to make sure that everything comes together on this. That's a first step to getting to what's called a moving block. So if we look at it, fixed block is how the rails run today. That you have the block that you're occupying. You want a gap between you and a train behind you. You need the train behind you would need movement authority to move into the next block. It's how it works. If we get to a moving block, now you're keeping the gaps between the trains fairly constant, sort of like adaptive cruise control in your car, where you can set what the gap is. These gaps are still fairly large because these trains can take a mile or two to stop when we think about how much weight are on these trains at this point. That'll help condense the space and allow for significant amounts of more rail traffic. And then virtual coupling is more similar to, say, platooning with trucks. We'll actually get them closer together. They'll be talking train to train. And if the train in front has better braking ability, you actually derate that to make sure that both trains are accelerating and decelerating the same as we're going through there. So these are all steps. There's been studies done in Europe that by going from fixed block to moving block to virtual coupling, you can get 46, 48% more traffic on those rails. We think we can do even better in the US while we're doing this. So PTC was a step to get all of the interoperability, all the communication technology in place. Now we need to continue to drive this as a controlling methodology, a way to go ahead and drive further safety into the system, and then we can get to the moving block and the virtual coupling. And by doing that, yeah, and just get back to the decarbonization. By doing that, rail per ton mile is about 4 to 5 times less carbon producing. So by moving more of the ton miles from trucks to rail, you'll naturally decarbonize the system.
Gotcha. So there's obviously a definite link there with that such an operational technology and net zero emissions. And just a last question I had for you, because obviously Wabtec is heavy into the rail sector, but I understand that the company recently won a contract to build the marine diesel engines for a hopper, a dredging hopper used for navigational dredging on the maritime side. It's a hopper named, from what I understand, the largest U.S. hopper dredge called the Frederick Paul. So I was just curious on, could you let us know, Eric, how Wabtec is also working on the marine side to reduce emissions as well?
Yeah, and this is a great example of taking technology that we have and moving it into adjacent markets. So we're utilizing our engines that we use for our locomotives, our Tier 4 locomotives, and we're applying this now to a marine application. And if you look at the emissions that are coming out of this, mostly around NOx and SOx and particulate matter, those types of controlled emissions, it's a 70% reduction in those emissions when you go to Tier 4 on these vessels. And so we've marinized it. You have to ruggedize it a little bit more because of the water environment, the salt water environment, the rest of the pieces there, and put it in there. Very similar to how we use our similar technology in the mining space and other spaces around that these are adjacencies that we can step into using our sustainability initiatives to make sure we're always driving down emissions while we do it.
Gotcha. Very interesting. Very interesting. Well, Eric, that's about all the time we have. Thank you very much again for taking time to provide us your insight on the rail industries and the move forward to net zero emissions.
Okay, thank you very much. I enjoyed the discussion.
And thanks everyone for joining us, and stay tuned for the next panel.